Okay, our next speaker is Alexandra Rybaritz, and she is a senior expert at the Austrian Agency of Health and Food Safety, AGES, and AGES in German. While she has a one-hand expertise specifically related to plant genetics, plant breeding, genetic engineering, but also in food security in times of climate crisis. So it could be quite interesting. And food security and climate crisis will be the bridge to the multidisciplinary teams that she joined on the national and international research level and capacity building projects. She studied agriculture at the University of Natural Sciences and Applied Life Sciences in Vienna and has a specialization on organic agriculture and plant and breeding. And of course, since she is in this session here, the challenges will go on, I would say, with your talk. Alexandra, the floor is yours.
Thank you very much for this very nice introduction. And I would also like to thank the organizers for the invitation to this very special conference. And I'm so happy to be here in Berlin and see many people whom I know for a very long time and some faces which I've only seen online so far. So it's just a great opportunity, so thanks a lot. We've heard a lot about the detection challenges, and identification seems to be even more challenging. And the whole conference deals with both aspects in the end, so with the detection, but also with the identification. And as has been said in the introduction, I work at the Austrian Agency for Health and Food Safety. And sometimes I feel like I'm in the epicenter of this detection and identification jungle. AGES, the Austrian Agency for Health and Food Safety, stands for protecting the health of humans, animals, plants, and soil, and for food security. And this is why I sometimes feel like being in the epicenter of NGTs, because on one hand, they give us some benefits, potential chances, especially when we think about the climate crisis. But then there are also some people who are concerned, and we should have a look at potential risks. And this is what we do. Who is, sorry for that. AGES is an agency, and it's owned by the Republic of Austria, and actually we have two ministries responsible for us, who are our owners. And also here we have quite some challenges, because on one hand it's the Ministry of Agriculture, on the other hand it's the Ministry for Health in the short terms. And here we also stand between the risk assessment and also the benefits and potential chances. And we are organized by a specific legal basis, namely the Health and Food Safety Act, where many of the things which we are dealing with every day are written down. The AGES cycle, it's more than plants, it's more than animals, so we have a whole cycle here in our house, and that's beautiful. So we start off with food security, which is basically the agriculture. We have animal health, and we know nowadays that NGTs also touch the animal field. Then food safety, this is exactly where the detection and identification takes place. Public health, climate crisis, medicines and medical devices, also here the NGTs are becoming more and more relevant. And then radiation protection, okay, I will not comment where this could be relevant. In any case, we do a lot in these fields. So we research, we monitor, we also make assessments, and we also communicate in the end, especially when it comes to critical situations. And if I want to say so, our clients are authorities, consumers, patients, but also the industry. So again, we are in a quite ambivalent surrounding. So what AGES is specifically doing in the field of GMO and also NGT, if we put it together, I feel that we are at the central interface, because we are dealing with the implementation We also do consultations, and many colleagues are involved in working groups internationally, but also in the EU. When it comes to the food safety, food security, and risk assessment, we are involved in all these aspects concerning GMOs and NGTs. So we do the monitoring and surveillance in Austria, including also the planning of the risk-based plans. Then variety and seed testing when it comes to the plants, but also we risk assess the applications for authorization. And with all this, we implement the European and the Austrian legal framework. This is probably important to note that we are not the authority, but we are an agency. We also do research and development to a large extent concerning GMOs and NGTs. We have started quite a long time ago, and I've been with Argus since 2009, and it was my very first project which already dealt with GMOs, and very soon we stepped into the NGT issue. And here we publish studies, we also make science-based assessments, and we do scientific and technical policy advice. And we deal with the challenges because we have to. So we have to deal with the detection and the identification challenges, but also we have to think about the political decisions that might take place. And scientific developments, of course, are very important. And we will hear a lot about this in the next 3 days or 2 days from tomorrow on. And we also deal with the expectations of the society. So you are well aware that in Austria, the GMO issue is a large one. So the society expects that we are gene-free, and we have to deal with this. Then we also have the stakeholders and the economic operators, like, for instance, breeding companies. What are the key considerations when we think about the current situation? So GMO traceability, as has already been mentioned, seems to be a consumer expectation. It's kind of similar to what is expected in the GMO field. And here clear specifications are important and necessary. This is important for us as labs who need to detect and to identify, but also for the economic operators and the consumers. And finally, also for the environment. We need legal certainty, and we need to have a defined legal framework because we need to implement that framework. So if there are some insecurities here, it could be complicated. The health and safety for humans, animals, and environment is always at the top, as I showed in the first slide. And here, the monitoring of known but also unknown GMOs is on the buffet. Economic considerations. When it comes to traceability, this might also be an important thing to think about because we already experienced in the past some trade interruptions due to, for instance, different legal frameworks in the GMO field, and the same could happen with genome-edited products. Then think about the organic and GMO-free economic fields. In Austria, organic farming is about 25%, so we have already reached what the EU wants from the EU. And it's a big issue, so people expect that organic is GMO-free. And then we also have diverse private free-from labels, and also here we have the requirement to trace and ideally also to have the analytical control. And as already mentioned, in Austria, this is a big issue. When it comes to the GMO, to the so-called classical GMOs, then information and material, which are the prerequisites to develop detection methods at all, as has been beautifully described by Malcolm before, this is given. So you have a description of detection and identification techniques for the GMO. You get the information which you need. You have the details on the nucleotide sequence in order to develop methods, but you also have a method provided by the applicant. You have everything which is necessary to detect, but also to identify. And you also usually have the reference material, because also this is an obligation, so the applicant has to provide the reference material. And we've already heard about the role of the EURL GMFF. I want to point out here, and I think this is also an important framing for the next days, that detection actually has two aspects. On one hand, you have the detection where you see that a GMO, or in our case now, what we're discussing, an NGT, is present, a particular genetic or phenotypic modification, and this can be detected by analytical means. It can be qualitative, which GMO, but it can also be quantitative, how much of the GMO, and their correct labeling is important, again, a requirement by the law when it comes to that mixtures. On the other hand, we have the identification. We've already heard that here it is important that we have a clear assignment to a specific plant or product, and ideally to a specific developer. And this is typically done by event-specific detection in case of the GMOs, as we've already seen. And usually you can assign this detection result to specific plants, products, or developers. It is very obvious why this can be done. Malcolm has already described this also, so thanks a lot. I can skip a bit. We have here random insertion, so we have this unique junction between the insert and the plant genome. And this is usually sufficient evidence for identifying a GMO because you have something which doesn't occur naturally. And here, event-specific methods can serve both aspects. They can serve for detection, but also for the identification of the GM plant. Malcolm has also mentioned that screening may be possible when we have these typical elements. And here also we can screen for unknown GMOs. I'm well aware that probably not for all of them, but to some extent this works. And then usually a multi-level approach is applied in the classical GMOs. And once more, to underline, the applicant needs to provide a material and method. So many things, many prerequisites are here for the classical GMOs. So the challenges in identification, when it comes to the NGTs, prior information is always needed. And we will hear about some possibilities how to get this information, like, for instance, databases. We need the information on the modified sequence. And this has already been commented today, that this can be a challenge in some cases. But you can also do information-based investigations and use of traceability systems. We will hear about this as well. As Malcolm also already pointed out, detection of very small changes in the genome are usually possible. It is possible if the mutation is known, but it can be, but is not necessarily technically challenging. But importantly, it does not show what has caused the modified sequence and the mutation. And usually, to the current state of knowledge and technology, we cannot deduce from our means of detection information on the applied technique. But probably this will be possible in the future. And what is also challenging, again, is the availability of reference material, because here not necessarily we have access to reference material, and this is already important in the method development phase, but even more in the quantification. When we think about the feasibility, so we have the SDN1 and the SDN2, which have already been described. The detection is obviously possible if the site is known. But we do not have this difference to traditionally mutated plants or naturally mutated or whatever you would like to call it. So in the end, you need to do a case-by-case investigation, and also this has already been touched, like multiple mutations could be investigated, specific traits, maybe there are specific traits which you cannot find naturally. And then also the issue of the classical screening elements. It would be interesting to find out whether there are specific patterns concerning the genome-edited plants. The SDN3 have also been mentioned. Detection is usually possible if the site is known. And it is also important to mention here that it can be a transgene. And when it is a transgene, you have the typical elements of the classical GMOs. So you have linkage regions again, and event-specific methods will be possible. What can be challenging, depending on the exact sequence, is if SDN3 is combined with the cisgene. So if you have, for instance, alleles which are replaced. What is important for the control activities? We need to have the technical considerations that the small changes is possible. We will hear a lot about possible technological solutions to that in the next days. It is of advantage if we think about PCR-based methods, because usually there you have the available equipment and expertise, but probably the PCRs will not lead us to the end, so we will think about other methods too. We also need to consider necessary limits of detection and quantification. This depends on the method applied. And again, think about the identification issue. Can it really be done by analytical means only? And as said, currently we cannot prove the type of the technique, and we should think about whether this is at all necessary. When it comes to management decisions that can aid the technical considerations, it's international databases for plants, but also for methods, international exchange of information, and I once more underline international, because it doesn't help if we just stay in the EU context in this case. Also, research on genomic alterations after genome editing would be very interesting, because maybe here we find some possibilities for identification on an analytical basis. But, however, we always have to think about the cost-benefit, risk-benefit issue, because whatever we decide to do, it will create costs, and we should think about whether we want it or not. The constraints, when it comes to the technical requirements, we need to develop methods. Either this can be done by the applicant, or it is done by some other labs, private or official. But when they do not have information, they are both on the same stage. Sequence reference databases. So we'll hear about sequencing in the next days too, and here it is important to see who is the comparator, what is the comparator, which reference is actually the reference sequence to be used to compare. The reference material issue, I'm very sorry, I cannot solve it at the moment, so this is an issue, and especially when it comes to the quantification. The technical prerequisites, I've already mentioned then, equipment, staff, and expertise, and together with this, the costs that are created when you have to buy new equipment, for instance. So still, we can think about the standard detection methods, but I believe that this will not be enough, so sequencing should also be considered, and we should have a second look. And what is also challenging to some extent is the political developments, because we know that decisions related to the regulatory framework are waiting for us. We are looking forward to have this clarity, as mentioned in the beginning. The other challenges to be considered are the international different legal requirements. So here we probably do not get the reference material and also not the information. Challenging. When we do not have the sufficient appropriate information, well, we have to think what to do. Again, the prerequisites, but also this has already been mentioned by Malcolm, uniqueness of the specific sequence change is important, or otherwise clearly assignable data. And combinatorial considerations can be made. Opportunities, when we have diverse sources of information, these may feed into a process where we reach the identification in the end, and these diverse sources can actually also aid the detection and identification strategies in the laboratories. And here we will need a broad cooperation, so not only of authorities, but also governmental agencies like AGES, researchers, and also companies and developers. And here the key element is the disclosure of information, and also information exchange on an international basis needs to be supported. We can also make use of best practice examples, governance of food product stewardship programs, governance networks that are already existing, and also existing databases. And with this, I would like to come to the end of my talk. with also pointing out these papers. If you have not had a look yet, then I kindly invite you to do so. And otherwise, I'm looking forward to the next days where we hear a lot about all these challenges, but also the opportunities. And thank you for your kind attention.